10.2 Arithmetic Sequences and Series. Here's the objective. We're going to learn two formulas in this section about arithmetic sequences. The first one is used to find any term in a sequence. We call this the nth term. All right, let's talk first about what we would have learned in the last lesson, that an arithmetic sequence is like a linear function and that the common difference is the same as the slope. Before I show you the formula for the nth term, I'm going to show you where it comes from. We're going to start out with the slope formula, and I'm going to substitute the m for slope for the d for common difference, since we said that the slope is like the common difference in an arithmetic sequence. Now I'm going to use the points n, a, n, and 1, a1 as my x and my y. So the 1, a1 is going to be my x1, y1, and then the n, a, n will be my x2, y2. So plugging those into the slope formula, I will have an minus a1 over n minus 1. I'm going to multiply both sides by n minus 1, so I'll have d times n minus 1 equals an minus a1, and then I'm going to add a1 to both sides. So I have a1 plus d times n minus 1 equals an. And that, my friends, is the formula for finding the nth term of an arithmetic series. Sequence. So you should copy down that formula. I have it here. The other formula we're going to learn later is the formula for the sum of an arithmetic sequence. And then up here you can see I'm just reminding you that for an arithmetic sequence you have a common difference, which means you're going to add something. You're going to add that difference to get to the next term. All right, let's find the 20th term of this arithmetic sequence. So according to the formula, let's write down the formula again. It's an equals a1 plus d times n minus 1, or n minus 1 times d, doesn't matter. We're going to find the 20th term. So n is 20, so I'm going to use that as my subscript. The first term is 3. The common difference, hopefully you can tell by looking at the sequence, is 7. And again, that's 20 minus 1. And when you calculate that, you get 136. So the 20th term is 136. Here's your first video quiz question. All right, in this example, we want to write an equation for the nth term of the sequence if we know that the sixth term is 11 and the difference is negative 11. Sometimes this type of question will ask you to write the formula for the nth term, and I'll show you what I mean. So let's write down again the formula. an equals a1 plus d times n minus 1. What I'm going to use is the fact that the sixth term is 11. So I'm going to substitute 11 for an, which means that I'm going to have to substitute 6 for n. And the common difference, of course, is negative 11. And a1, I don't know what that is. This can be challenging sometimes for students to understand what I plugged in and why. The sixth term is 11, so I plug that in for an. And then if n is 6, then the term itself is 11. I don't think that helped, but ask me in class if you don't understand this. Okay, so we have 11 equals a1 plus negative 11 times 5. So 11 equals a1 plus, actually we should say minus 55. So a1 is going to be 66. Okay, so that's very useful. We have the first term, and we were given the difference, so now we have enough to write a formula or an equation for the nth term. So let's write down the formula one more time. an equals a1 plus d times n minus 1. So we're going to write this in general terms now. We want to know like an equation or a formula. The first term is 66. The difference is negative 11. And we're going to leave the n in the equation, and that's what makes it the little formula. I'm just going to clean it up. So I'm going to distribute the negative 11. So there's 66 minus 11n plus 11. Combine the 66 and 11 to get 77 minus 11n. And there's my formula or equation for the nth term. Here's your second video quiz question. All right, this one is asking us to find the arithmetic means in a particular sequence. Now, when they're saying arithmetic means, what they're really asking for are like missing terms. We're trying to find the terms that fall between 21 and 45, and there's 3 of them, and all 5 terms together are going to form an arithmetic sequence. So there are a couple of ways that you can approach this, especially if you're thinking about it in terms of a linear equation. One way that I do this is I think about, well, to get from the 21 to the next term, I would have to add one common difference. Then to get from the second term to the third term, I'd have to add another common difference. From the third term to the fourth term, I'd have to add yet another common difference. And from the fourth term to the 45, I'd have to add another common difference. So basically, 21 plus 4 common differences is going to equal 45. So I can easily solve for the common difference, and I get 6. So now that I know that the common difference is 6, I can easily go back up and say, well, if the first term is 21 and the common difference is 6, the next term is going to be 27, and the next term will be 33. The next term will be 39, and you could check that if you do 39 plus 6, you do in fact get 45. So your 3 arithmetic means are 27, 33, and 39. Let's talk about finding the sum of an arithmetic series. To generate the formula for the sum of an arithmetic series, let's consider all the integers between 1 and 100. If I asked you to add up all the numbers from 1 to 100, you could easily do it with your calculator. It might take you a few minutes and it would be a little tedious. But think about this. If you were to pair the first number with the last number, and the second number with the second to last number, and the third number with the third to the last number, and so on and so forth, eventually you would pair 49 with 52 and 50 with 51. What do each of these pairs sum to? They sum to 101. 1 plus 100 is 101, 2 plus 99 is 101, 3 and 98, and so on. Well, how many pairs of these numbers do you have? You have 50 pairs. So if you have 50 pairs of numbers and each pair sums to 101, how can you find the total sum? Well, that's going to be 50 times 101, which is 5,050, which is the sum of all of the integers between 1 and 100. Well, how did we figure that out? Well, we took the total number of numbers that we had, 100, but we paired them off. So we have to cut that in half to find the number of pairs. Then we had to figure out what each pair adds up to. So we took the first number, which was 1, and we added to the last number, which was 100. So then you get the 50 times 101. This leads us to this formula, which is the formula for finding the sum of an arithmetic series. You take the number of numbers that you have, you divide by 2, and you're going to multiply that by the sum of the first number plus the last number. In other words, this formula right here. This second formula right here, I'm not going to show you where it comes from, but I will tell you that what it does, or where it comes from, is that if you take the an from this sum formula and you substitute it with this formula for the nth term, substitute this expression into here, clean it up a little bit, and you will get this formula here. You should write both of these down. They're both important. So let's use one of those formulas. We want to find the sum of the sequence where the first 3 terms are 7, 9.5, and 12, and we want to find the sum of the first 101 terms. Well, looking at that first formula, that requires that I know the first term plus the last term. In this case, that would mean the 101st term. But I don't know the 101st term. So I'm actually going to use the other formula, which says n over 2, 2 times a1 plus d times n minus 1. So for this formula, I just need to know the number of numbers I'm adding up, that's n. I need to know the first term, I need to know the common difference. And I have all that information. So 101 over 2 times 2 times 7 plus the common difference, you can see, is 2.5 times 101 minus 1. And when you calculate that, you're going to get 13,332. So the sum of the first 101 numbers of this sequence are 13,332. Let's do another example. We're also finding the sum of this sequence. This time we do know the last term, the value of it, but we don't know its position. In other words, we don't know n. We don't know the number of numbers that we're adding up. So I need to find out where 80 falls in that sequence. So I'm going to go back to my nth term formula from earlier, and I'm going to solve for n, given that the a sub n, or the nth term, is 80. The first term is 8. The common difference is 4, n minus 1. So subtract the 8, we have 72 equals 4 times n minus 1. I'm going to divide by 4, and that'll give me 18 equals n minus 1, so n equals 19. So this means that 80 is the 19th term, which is useful since I now know that I'm finding the sum of the first 19 terms. So that's 19 over 2. The first term is 8. The 19th term is 80. So when you calculate that, you're going to get 836. So the sum of the first 19 terms is 836. Here's your third video quiz question. We're going to find the first 3 terms of this series if we know the first term and the nth term and the sum. Well, again, what we don't know here is we don't know the value of n. We don't know how many terms we added up to get 129. We don't know the common difference, and we don't know where 29 falls in this particular series. So we are going to use the sum formula, since that's the only information that we really have. So n over 2, a1 plus an. I'm going to plug in what I know. I know that's 129 equals n over 2, 14 plus 29. You're going to solve for n there, and you're going to get 6. 6 equals n. I still don't know the common difference, but I can use the nth term formula to find the common difference. Here's a formula again, d times n minus 1. The nth term, we're going to use 29 again, because I now know that that's the 6th term. The first term is 14. The common difference I don't know, and n would be 6 in this case. So we're now solving for d, and you're going to get 3. So if your common difference is 3, and your first term is 14, so you have 14 plus 3, the next term would be 17, plus 3 more, the next term would be 20. So these are the first 3 terms.